Okay, this question says log base 3 by 4 of x to log base 8 of x square plus 7. So it says log base 3 by 4 of log base 8 of x square plus 7 plus log base 1 by 2, okay, plus log base 1 by 2 of log base 1 by 4 of x square plus 7 to the negative 1 power. That's a big question. That is supposed to be equal to negative 2. So how do we do this? First of all, you see that you got log base 1 by 4 of x square plus 7 to the negative 1 power, right? That thing, okay, so log base 1 by 4 of x square plus 7 to the negative 1 power, that is the same as saying negative log base 1 by 4 to the x square plus 7 power, which is the same as saying negative 1 upon negative 1 upon log base x square plus 7 of 1 by 4 power, which is the same as saying 1 upon log base x square plus 7 of 4, right? Okay, which is log base x square plus 7 of 4, all that raised to the negative 1 power. That's nice. So we can just substitute it in place of that disastrous thing. Okay, and similarly we can do something over there. So log base 3 by 4, and this thing can be written as 1 upon log base x squared. 1 upon is the same as saying negative 1 power. So log base x squared plus 7 of 8 raised to the negative 1 power, and plus log base 1 by 2 of, okay, this guy we just wrote before that, so x squared plus 7 to the fourth, okay, of 4 raised to the negative 1 power. It has to equal to negative 2. Alright, so now we can bring this negative 1 on the front and this negative 1 on the front, and it will cancel with this negative to make it positive. So it will be log base 3 by 4 of log base x squared plus 7 of 8. But now I'm going to write 8 as something which will be much better to understand. Okay, 3 by 4 of, I'm going to write it as 16 raised to the 3 by 4 power. Okay, plus log base half of log base x squared plus 7 of 4, but 4 is nothing but 16 raised to the half power. Alright, and you got these negative ones cancelled out and it gave me 2. Okay, so this thing is going to be log base 3 by 4 of 3 by 4 into log base x squared plus 7 of 16 plus log base 1 by 2 of 1 by 2 into log base x squared plus 7 of 16 equals to 2. So now you can use that rule of log base a of m into n, and we can write it as, well, log base 3 by 4 of 3 by 4, that's just 1, plus log base 3 by 4 of log base x squared plus 7 of 16, yes, plus log, okay, plus 1, because log base half of half is just 1, plus log base 1 by 2 of log base x squared plus 7 of 16. Okay, that has to equal to 2, so this cancels, you got 0 over there, no problem. And now just for my ease, I'm going to write log base x squared plus 7 of 16 as a. So that gives me log base 3 by 4 of a equals to negative log base 1 by 2 of a, which is the same as saying that if you take the reciprocal, I mean that's going to be 1 upon log base of a of 3 by 4 equals to negative 1 upon log base a of 1 by 2, very obvious. So that gives me log base a of 3 by 4 equals to negative log base a of 1 by 2. Okay, that's nice. That is almost it. So log base a of 3 by 4 into 1 by 2, right, because it's going to be addition between logs, so multiplication in the insides. So 3 by 4 into 1 by 2, and that has to be equal to, guess what, 0. No problem. That gives me log base a of, wait a second, oh shit, it has to be 0. Okay, yes, it's fairly obvious. No problem. Mm-hmm. Yeah, we took this equation and just modified it. Nope, no problem yet. So yes, it is completely okay to do that. And let's just see what value of x we get. If it doesn't satisfy the equation, then okay, we'll just let that be. We'll say that we have made some kind of mistake somewhere. No problem. So log base a of 3 by 4 into 1 by 2, that's going to be 3 upon 8. Yes, I think that's correct. That has to be equal to 0. Wait a second, that can happen only when 3 by 8 uh that's equal to 1. No, that's not nice. 3 by 8, that cannot be 1. So how else can this be equal to 0? Well, that is weird. So 3 by 4 into 1 by 2, that is not 1. So, and still it's equal to 0. When does that happen? I don't know. We have indeed made some kind of mistake somewhere. So what did we do? Okay, let's just start once again from here. Let's see if we made some kind of mistake. So we took log base x squared plus 7 of 16 as a. So that gave me log base 3 by 4 of a plus log base, okay, log base 1 by 2 of a has to be equal to 0. Okay, that gave me 1 upon log base a of 3 by 4 plus 1 upon log base a of 1 by 2 equals to 0. Sorry. Okay, uh yes, 1 upon 2 equals to 0. What we did was we moved it over here, and then we took the reciprocals. That could have been okay, uh, but what if the reciprocals we took, that's not correct? In that case, it would not be okay. Alright. Well, obviously those were not 0, so it's okay to take that reciprocal, I think. Yes. Yeah, log base 3 by 8 equals to 0. That's it. That's what we are getting. Why is it not working? You got 1 over there. It's got that 3 by 4 out, and then you got log base 3 by 4 of this thing. You wrote it as 1 plus log base 3 by 4 of log base x squared plus 7 of 16. Alright, that's all working very nicely. That should have been equal to 0. Alright, which means that these have to be the negatives of each other. So you got log base 3 by 4 of a equals to negative log base 1 by 2 of a. I think yes, that gives me 1 upon log base a of 3 by 4 equals to negative 1 upon log base a of 1 by 2. So log base a of 3 by 4 into 1 by 2, that's supposed to be equal to 0. It's supposed to be equal to 0, but why? How is that so? I don't know. These are supposed to be negatives of each other. I don't know. Am I making some kind of mistake once again? So you got negative 1 over there. That's the same as saying log base. Alright. No, I don't think so that I'm making any kind of mistake. So that can be written as log base 4 of x squared plus 7. Yes, which can be written as log base of x squared plus 7 of 4 raised to the negative 1 power. should be equal to 2. Solve for the positive value of x. It satisfies. Okay, and then we took that -1 on the front. No problem, we can do that. There's no problem with that. So that gave me this equation, which we modify to that equation. So 3 by 4. Yes, 2 raised to 3 is 8, but 16 raised to 1 by 4 is 2. So that's nice. 16 raised to 3 by 4. You got 16 raised to 1 by 2. Very obvious. So you got 3 by 4 into that guy and 1 by 2 into that guy. That should have cancelled the 2. And we should be getting this equation. But now something's just not matching up. Alright. So yeah, that's what we are getting. We are getting that log base a of 3 by 8 is 0. How can it be 0? I mean, 3 by 8 is not 1, so it should not be 0, but it is. Somehow it is. Still not know why. Okay. Fine. Let's do it with a different strategy this time. This time I will bring the 2 inside and let's see what happens. I think this should have given us some nice answer, but it didn't. So whatever. I don't know what's going on. It's like this is never true for any value of x. Can it be like that? I don't think so. I think that's not correct. So this time what I will do is I will write it as like this. Okay, log base 3 by 4 of log base 8 of x squared plus 7. Okay, plus 1 is equals to, you got -1 over there, that's fine. So it's going to be minus of log base half of log base 1 by 4 of x squared plus 1 raised to the -1 power. Okay, and then plus 1, so it's going to be, yes, it's going to be negative of that. Okay, so now this thing can be written as log base 3 by 4 of log base 8 of x squared plus 7 into 3 by 4, right, which is nice. So into 3 by 4, yes, pretty much like that. And similarly this can be written as negative log base 1 by 2 of it's supposed to be log base 1 by 4 of log base 1 by 4 into x squared plus 7 raised to the -1 power, but this times 1 by 2. That is the same as saying log base 3 by 4 of, now I'm going to write it as 3 by 4 into yes, into 1 upon log base x squared plus 7 of 8 equals to negative log base half of, alright, this has to be some weird thing. Okay, log base half, so that -1 can go on the front. Okay, yes, so it's going to be 1 by 2 log base 4 of x squared plus 7, but that can be done as 1 upon log base x squared plus 7 of 4. We are pretty much doing the same thing which we did before. I am not sure this is going to give me anything nice, so yes, that's fine, and that's what we are getting till now. So it's going to be log base 3 by 4 of, well, 8 can be written as 16 raised to 3 by 4 power, so that cancels. You got 1 upon log base x squared plus 7 of 8 equals I mean of 16 obviously, of 16, so that cancels with this guy, right? That is to be equal to negative log base half of, doing similar stuff over here, you get negative log base x squared plus 7 of 16. No problem with that. So that gave me um yes, that gives me negative log base 3 by 4 of log base x squared plus 7 of 16 has to be equal to the positive log base 1 by 2 of log base x squared plus 7 16. Wait a second. Now I could take the reciprocal. That would obviously make it, I mean, yeah, another equation which can be solvable, but it's not. And I think why it is not is because what if this value is 0, I mean this value is equals to 1. In that case, the left hand side and right hand side both would be turning out to be 0, so that would be very nice. So if log base x squared plus 7 of 16 equals to 1, then we are done. Yes, that is in fact the solution. So that gives me 16 equals to x squared plus 7. Easy as that. So that gives me x squared equals to 16 minus 7. That's going to be 9. So x equals to 3 because we have to find the positive value. That's it. It's easy as that. Why did I even bother to make another equation out of it? It could have been solved at this stage only. Okay. You do not need to take the reciprocals and then use that change of base rule. No. We can do it directly. So yes, that was nice. And taking reciprocal was not allowed because what if these are already 0? So that's another thing to keep in mind, that before taking reciprocals you also have to consider the condition that it may be possible that both of them are actually 0. So yeah, in that case taking reciprocals would not be a good thing. So yeah, that's why we couldn't get it the first time. But yes, the method is supposed to be exactly what we did both times, so yes, that's correct. Fine. So x equals to 3 is the only solution.